going to be on special case rules. Here we're going to learn how to do things fast, and I'm going to make this video fast. We use a special case to solve problems as shortcuts. Shortcuts when we have binomials. When you learn this, you'll hear a squared plus 2ab plus b squared equals the sum of a square. And if you're anything like me, when you hear that, you're going to be confused and you're not going to understand it. But my recommendation for you is to make sure that you understand how to multiply binomials and you've done a good amount of practice problems before you even worry about trying to remember the special rules. Learn the long cut before you learn the shortcut. But I digress. Moving on to the subject of the video. What is a squared plus 2ab plus b squared? The a term is here, the b term is here, and that's what you need to know. A on the left, b on the right. So this will be as simple as 3x squared, which is 9x squared, plus 2ab, that's a times b. So 3x times 5, 15 times 2. So we have 15x times 2. So that will be 30x. Okay, and now for the b squared, what's 5 squared? That would be 25. So this is your a term, b, 2ab, and b squared. Let's try the second question here. This is the second special rule, a square of a binomial difference. That would be in the mumbo jumbo of algebra, a squared minus 2ab plus b squared. Okay, that applies to these equations. When you have a first term with a variable minus a constant or integer squared. So a squared, what's 2a times 2a? That would be 4a squared. All right, now we have minus 2ab. Now important point here is don't try to include this negative sign in your calculations. This negative sign is its own entity. So what you're going to get is going to be what you're going to get is still going to be subtracted. Okay, so let me explain that. A squared we know is 4a squared. Okay, now we have 2 times a times b. A is 2a, b is negative 7, so minus 28a. Now b squared, b will always be a positive number because it's a square, so we have negative 7 squared, which is 49. That is your answer for question number 2, square of a binomial in the case of a difference. All right, your third special case, this is the easiest one to remember, product of a sum and difference. So they're saying 4y plus 9 multiplied by 4y minus 9 is always going to come out in the form of a squared plus b squared. So when you see an equation in this form, you know you're going to get a squared plus b squared. So, and the reason for that is these two middle terms cancel each other out. So let's see here. What's 4y squared? That is 16y squared. And we're going to add, what's 9 squared? That is 81. Okay. This is the product of a sum and difference of squares. All right, final one, perfect square check. Now we're going to see if this is a perfect square trinomial. A perfect square trinomial is simply a trinomial that can break into one of the special cases you just learned, meaning that it can be it could be any of the above three. It could be 4y plus 9. Well, sorry, it couldn't be this one because this doesn't create a trinomial. It could be this one, a square of a binomial difference. So 2a minus 7 squared, or could be 3x plus 5. So the key thing there is that if it's asking for a perfect square trinomial, it will be able to break down into a x plus or minus, or actually x plus, and an x. Now it'll be plus or minus something. Okay, I see I have positive terms. So in this case, it will be plus for both. So we're going to determine if this is a perfect square trinomial. A good hint on a perfect square trinomial is the last term, the c term, is that a perfect square? We know that 36 is a perfect square because 36 breaks into a number times itself, 6 times 6. So what that tells us is that the answer is that it is a perfect square trinomial. The form of that perfect square trinomial is x plus 6, and it can also be written as x plus 6 squared. Thank you for watching my video on special case binomials. Now, bye binomials.